Very much for having me here today. Yeah, as Lucas said, I'm leading the development of the application layer for Eternity. So what we do is we don't work on the core blockchain technology, but everything around it that is needed to develop apps, especially decentralized apps on top of the Eternity blockchain technology. Short introduction, my team, we're around 10 developers. Also our team's decentralized as the applications we're working on. And we have a couple of UI and UX designers to make sure we have like a frictionless user experience at the end of the day. So today I'll talk a little bit about the challenges that come with developing decentralized applications based on blockchain technology and how we're trying to solve them with Eternity as an apps platform. So for decentralized applications, we basically shift our trust from the old web where we trusted individuals or organizations into technical solutions that are based on code and driven mostly by incentives of their participants. So the big question is, how do we make sure that this code does what we want and behaves in the way as we intended it? For your app projects, this is especially important about smart contracts. And I will show you a little bit what's the Eternity approach to solve this. So the biggest thing is that we try to remove complexity from the smart contracts and allow and have a lot of features already natively built inside the blockchain protocol. So we call them first-class objects. I will tell you a little bit more what kind of features you can expect to build your applications. So that makes the smart contract itself that you have to build way simpler and also cheaper because the execution can be more efficient. What do we have as first-class objects? We have oracles, we have names, we have state channels, and we have a governance solution. Oracles always become important if you want to interact with real-world data and process them in your smart contracts. That is used for a lot of use cases like insurance rates, but also query exchange rates. If you want to bridge into other systems, you could use for sensors, for data migrations from other chains, all these kind of things. And you don't need to build oracles on yourself. They're already there and you can just access them. Another thing is when it comes to usability, that addresses and public key pairs are, for humans, very difficult to compare and to make sure that this is really the key pair. They're very long, they're very cryptic. So in Eternity, we have a built-in naming system that allows everyone to claim a name and use this name instead of the address. State channels. So a lot of transactions need to be in the chain and visible for everyone. But very often you have the use case that you need transaction with a really high volume, and it would be way too expensive to have all these transactions on chain. So Eternity features a mechanism that allows you to just save the agreement that you want to do transactions with someone up to a certain amount on the chain itself, and then do all the transactions off chain. As long as both participants agree on it, everything is fine. If not, you can always go back to the chain and escalate the process there. You can also run smart contracts inside these channels, which also gives you another feature, and that is privacy. You don't have to publish everything that is happening there. You just have to publish parts of it if you want to escalate back to the chain. And this is also a very important feature. So with Eternity as an app platform right now, we can solve current issues that we see that prevent blockchain applications and decentralized apps from mass adoption. But in the future, there will come new challenges, and to make sure that we can also react to them and adapt to them, we will implement a governance model within our blockchain protocol that is used for signaling and reach consensus between the different participants in the system. We use this governance model and this polls and voting system for æternity, for our governance, but you can also use it in your projects. So you will also be able to create polls and process the results in your smart contracts. We use a mechanism that we call delegated weighted voting, which means the amount of AE determines how many votes you have, and you can delegate your votes to another address. This is important. You might not trust yourself in a topic, or you might not have the expertise, so you want to delegate your votes to another natural person that you know, but it might be also that a lot of your funds are in a secured by offline signing solution or in a kind of vault that you cannot access them all the time, and you don't want to vote with the address where the funds lay around, so you can delegate your votes to another address for your daily use and vote with that one. So these are all features that are already implemented on the protocol level. So another way to make smart contracts safer is what we do is develop a new smart contract language that makes it safer to execute this language. We call it language Sophia, actually based on also, now I'm Sophia, so of course I had to show the map, but it's actually derived from the word wisdom. Yeah, what kind of language is this? It belongs to the ML family. It's a functional programming language. We choose the functional paradigm because there are fewer side effects and it's easier to read code components and understand what they do. It is strongly typed, so you can specify and automatically prove them that the certain properties of your smart contracts really behave in the way it is intended. And it gives you native access to all these features that I named before. We aim on a later level that you can even mathematically prove that your smart contract is behaving in the intended way. That is like what's called formal verification. And this is something that will come later and that will give you an extra level of security for your contracts. So this was like a lot about the challenge, how do we establish trust into the system of smart contracts. And now I will talk a little bit about the challenge of UX challenges of blockchain applications and what we do to address them. So one big problem is the interactive performance of current blockchain systems. So as users of digital products, we're used that almost everything goes in real time. And when I click a button, I want to have a response. In current system, that takes up to several seconds, minutes. So we try to address this. And another thing is that in current implementations, almost every action will cost you transaction fees. So we have two techniques to tackle this. One is called microblocks. We're implementing an approach that's called Bitcoin NG. And actually, instead of mining a block every couple of minutes, we have small microblocks that contain transactions every 2-3 seconds. So that really improves the response rate of our blockchain and also helps us with the transaction volume in total to handle that. Another technique I mentioned already are state channels, where you can go completely off-chain and really work in real time if your applications need that. So for the user experience, one other big challenge is combining security and convenience for decentralized apps. In the blockchain world, as you probably know, we don't have a password reset function. So to help the users to manage keep their secrets secure, not only like that they don't go public, but also secure in a way that they don't lose them, that they keep them safe. We develop a couple of mechanics. First is we have a mobile-first approach. That means your mobile phone is your first device in the æternity ecosystem. This is where your secrets are stored. We don't export them into several devices. They're only in one place. You can use, of course, other devices, but signing requests will be always tunneled through your mobile phone. We have an offline signing solution from the beginning that seamlessly integrates with a place where you also handle your accounts that you use on a daily basis. So from day one, you will be able to also secure big amounts of funds in a different device that is not accessible from the internet at all and provides an extra level of security. We call them vaults. We have an app ecosystem that, where you can publish your applications and users can find them. That helps you a little bit with the distribution. And we build a couple of essential apps that where you can also copy and paste code that's all open source and build something better or adapt it as you use it, as you need it for your projects. Another function that we have when it comes to key management is what we call social recovery. So as we learned already from the guys from YouTube, the people you trust most are your friends or your family. And what we do is that you can split up your secrets in 3, 4, 5 parts, share it with people you trust. One person alone won't be able to recover your secret, but if these people combine their secrets, they can help you to recover your secret. That is kind of our way to do a password reset. What else do we do? We have a couple of example apps that show you the basic functionality of æternity and also help a little bit with to get more users into the system. Another feature is that we try to provide ways to link with other platforms and existing systems that have already users, so that it helps you also to get them from there into your applications and help you with the user acquisition. Other than that, we have interface components that can help you to prototype them. Again, everything's open source. You can use them, you can modify them. They're responsive. That's it.